There are three nodes we modify for the scope of this project: a PD controller, an image processor, and a distance publisher. The distance publisher publishes three different values through three different topics. Each value is used for a different purpose by the controller after receiving an array of distances from the LiDAR node. The error value is computed by applying a trigonometric function to multiple measurements at different angles, which are then averaged and then published. The error value helps keep the vehicle at a certain distance from the wall. The distance value represents the distance of the vehicle from a specific angle for the purpose of determining if there is no more wall to follow to the right side of the vehicle. The front distance value is just the distance measured at the front of the vehicle. The controller listens to four different topics. Every time a topic is updated, a callback function alters the state of variables defined within the node. The controller then computes the steering angle and the velocity of the vehicle. The controller can be in one of the three states. Follow the wall, which can be considered as a default status for when there is no reason for the vehicle to turn right or left. Just adjust the steering angle to follow a wall. React to the circle. When the circle is detected with a sufficient radius to filter out false positives, and the front distance is within the acceptable parameters to make an abrupt turn to the left. And the last state, it checks for the right turn in case the wall is not being present anymore, in which case the vehicle turns to the right until it finds the wall. Due to the latency of the Z node and the processing time at the controller level, and due to the lack of a potentiometer in the provided hardware, the velocity of the vehicle was capped at a certain speed by alternating between turning on and off the motor. The color node receives a frame from the Z camera node. Each frame is processed to detect the presence or the absence of red circles. The data is transferred to the controller as a string. If there is no circle detected, the data contains a string value saying nothing detected. Otherwise, it would contain the radius of the circle that was detected in that frame. What you can see here is the footage of the Z camera with information gathered with OpenCV overlaid on top of it. We can gather information about elements on each frame, such as the position and radius of the red circle. While detecting red circles, it is very easy to get false positives, so the controller filters them out by only considering circles of a certain radius. At this point, the vehicle sees the red dot through the Z camera, and the LiDAR returns a value from the front distance that is more than 1.25 meters. So the controller then decides to choose the state where it has to turn left. At this point, the LiDAR measures distance at an angle of 60 degrees and finds that there is no more wall, which triggers the controller to initiate a right turn procedure. Once more, the vehicle sees the circle and turns until it loses sight of it. Once the vehicle loses sight of the red circle, the follow the wall state is activated again, and the controller starts using the error value to keep the vehicle at a certain distance from the wall.